Humbert here, and today we're going to be doing Unit 9, Notes 10. So we're going to be talking about multiplying rational expressions with polynomials. So whenever we have a polynomial, we're going to have to factor, we're going to have to do some sort of greatest common factor work in order to take out factors. So we're going to have to start by factoring everything that we see. We need to factor everything, just factor the crap out of everything until we get every denominator and numerator simplified. Then we want to find the excluded value at the beginning, and then we're going to cross off any overlapping factors on the top and on the bottom. Alright, so let's take a look at number 1. So for number 1, we want to simplify the following rational expression. So we need to start by factoring. So first of all, I know that I can factor this trinomial right here. So I'm multiplying to negative 15 and adding to negative 2. Again, throughout this course of the unit, we're going to be using easy way factoring. So that's going to be a negative 5 and a positive 3. So what I'm going to do is I'm going to go ahead and write everything out as is, as if everything were all multiplied together. So when I factor this out, I get x minus 5 and x plus 3. Again, using that easy way factoring. So I get x minus 5 and x plus 3. So before I cancel anything out, I actually want to calculate out my excluded value right now to make sure that I don't lose any factors, because I need to take this version of the denominator here. So those cannot be equal to 0. So I'm getting that x cannot be equal to 0, x minus 5 cannot be equal to 0, and x plus 3 cannot be equal to 0. So then I get that x cannot be equal to 0. When you solve this, you'll add 5 to both sides, so x cannot be equal to 5. When you solve this, you'll subtract 3 from both sides, so x cannot be equal to negative 3. So those are your excluded values. So now I want to take and I want to simplify this version right here. So I know that I can cancel out the x minus 5s. So I can cancel those out. Okay? Just getting rid of this circle so I have more space. Okay. Then I see I have x. Oops. I want my pen. So I say I have x and I have x squared. Well, this x is going to cancel out the squared right here. So I just have an x left on top. And then on the bottom, all I have left is this x plus 3. So this is my simplified rational expression right there. I crossed out the x minus 5s, and I was left with that. Taking a look at number 2, let's go ahead and let's set up our x. So when we set up our x, we're going to just be factoring that bottom one. So we're multiplying to 12 and adding to 7. Well, that's going to be 4 and 3. Again, if you're struggling with this factoring portion, please come talk to me. At this point, I'm kind of assuming that you're comfortable with it. I'd be more than happy to help you if you're not. So then we're going to write out our version. So we have x plus 3, and that's going to be multiplied times 5, divided by x. And now I'm going to write in my factored version, which is x plus 4, x plus 3. Okay, so now I want to find my excluded values with that original bottom. So I'm saying x times x plus 4 times x plus 3 cannot equal 0. So then we want to go ahead and say, okay, x cannot equal 0, x plus 4 cannot equal 0, and x plus 3 cannot equal 0. Oops, x plus 3. So then we get that x is not equal to 0. Solve this one for x and you get negative 4. Solve this one for x and you get negative 3. If you're not sure how I got those, come talk to me. Let's take a look at it. So then now let's go ahead and simplify this guy up here. So I can cancel out our x plus 3's. Okay, and when I cancel out the x plus 3's, I'm left with 5 up top, and then I have x times x plus 4 on the bottom. Now I'm not done here. I have to simplify in that x. So I have 5 up top, and then on the bottom, x times x is x squared, and 4 times x is 4x. So we have 5 divided by x squared plus 4x for that one. Okay, so let's take a look at number 3. So to start off with, we need to factor using the x. So we're multiplying to negative 4 and adding to negative 3. So that's going to be negative 4 and positive 1 up top. So I have x minus 4, oops, we're using y. So I have y minus 4 times y plus 1, and we also have y plus 5 up top. Then on the bottom, we have y plus 5. And then here we're taking out a y, okay, because we notice we have y squared minus 4y. So from each of those, I can take out a y. and then we're left with y minus 4. So before I cross anything out, I want to find the excluded value with that denominator, so I make sure that I don't lose anything. So I'm saying, okay, that cannot be equal to 0. So y plus 5 cannot be equal to 0, y cannot be equal to 0, and y minus 4 cannot be equal to 0. So then if y plus 5 is not equal to 0, y cannot be equal to negative 5, y cannot be equal to 0, and y cannot be equal to 4. So that right there is all of your excluded values. Now we need to start canceling some things out. Well, I can cancel out the y plus 5 factors. I can cancel out the y minus 4 factors. So what I end up getting is y plus 1 on the top and then y on the bottom. So I have y plus 1 up top and y on the bottom. So that right there is your final answer for number 3 there. And we can't cancel out the y's because of the addition. So now for this one, we're setting up two x's. We're multiplying to a positive 3 and adding to a negative 4. That's going to be negative 3 and negative 1. We're multiplying to a negative 30 and adding to a negative 7. That's going to be a negative 10 and a positive 3. So let's write out our factors. So we have this original b plus 3. And then when we factored this one, we got this x right here. So we have b minus 3 and b minus 1 up top. Then on the bottom, when I have 4b and I have 12, I need to take out a greatest common factor because 4b and 12 are both divisible by 4. So I could take out a 4 and I'm left with b minus 3. And then when I factored this x, I had b minus 10 and b plus 3. So now I need to go ahead and calculate out my excluded values. So b minus 3 cannot be equal to 0, b minus 10 cannot be equal to 0, and b plus 3 cannot be equal to 0. So solving each of those for b, I get that b cannot be 3, 10, or negative 3. Okay? Now let's go and simplify. So we can cancel out b minus 3, oops, wrong one, Miss Humbert, the b minus 3's, and the b plus 3's. We cannot cancel out the b minus 1, so that's going to stay up top. And on the bottom, we still have 4 and b minus 10. Now I do have to actually go through the work of simplifying that in. So I get b minus 1 divided by 4b minus 40 when you take that 4 and multiply it by each thing. So let's go ahead and let's take a look at number 5. So for number 5, all I have to do is 1x. So I'm multiplying to 12 and adding to 7. So that's going to give me 4 and 3. So then up top, I have x squared times x minus 5. You can flip the order of them if you want. The order of the multiplication actually doesn't matter. Then I have x times x plus 4 times x plus 3. So I want to start by getting my excluded values. So I have x times x plus 4 times x plus 3, and that cannot be equal to 0. So x is not equal to 0, x plus 4 is not equal to 0, and x plus 3 is not equal to 0. So x cannot be equal to 0, negative 4, or negative 3. So those are our excluded values. Then let's cancel some stuff off. Well, this x will cancel out the x squared up top. So then up top, I have x times x minus 5. And I can't cancel out any factors, so I actually have x minus 4 and x plus 4 and x plus 3 left on the bottom. Now, normally we'd multiply using the box method to get those multiplied back together, but this is the trinomial that we originally factored. So I know that it's going to be x squared plus 7x plus 12. So I basically factored it for no reason. Sucks to be me, I guess. So then I'm going to distribute in that x. So I get x squared minus 5x. Now nothing can be simplified anymore because there are no more multiplications. Taking a look at number 6. So for number 6, we want to factor everything as much as we can. So we have two x's that we need to factor. Multiplying to 6 and adding to negative 5. That's going to be negative 3 and negative 2. Multiplying to negative 6 and adding to negative 1, negative 3, and positive 2. So let's go ahead and let's write that out. So I have x minus 3, and then from that first x there, x minus 3, x minus 2. And then on the bottom, when I have that 2x and minus 4, both 2 and 4 are divisible by 2. So I'm going to go ahead and take out a 2, and I'm left with x minus 2. And then here is my factored x for that trinomial down there. So I have x minus 3, x plus 2. So now what I need to do is I need to set up my excluded values. So x minus 2 cannot equal 0, x minus 3 cannot equal 0, and x plus 2 cannot equal 0. So then we get that x cannot be 2, 3, or negative 2 for those excluded values. So now that I've gotten the excluded values of my original version, I can cancel some stuff out. I can cancel out the x minus 3's. I can cancel out an x minus 2. So then left up top, I have x minus 3. And then on the bottom, I have 2 times x plus 2. Again, I do have to distribute that 2 back in. So then I get x minus 3 divided by 2 times x is 2x, and 2 times 2 is 4. So I get x minus 3 divided by 2x plus 4 for my final answer for that one. Okay, let's take a look at number 7. So we have a lot of x's that we need to do. We actually have 4 x's. So for the first one, we're multiplying to negative 1 and adding to 0. That's the x squared minus 1. Well, that's going to be 1 and negative 1. For this one, we're multiplying to negative 25 and adding to 0. That's going to be 5 and negative 5. For this one, we're adding to 10, multiplying to negative 7. That's going to be negative 5 and 2. For this one, we're multiplying to 5, adding to 6. That's going to be 5 and 1. Hoofda! So now I need to go ahead and write out all of my factors. So I have x plus 1, x minus 1, x plus 5, x minus 5, all on top. And then on the bottom, I'm going to have x minus 5, x plus 2, and then x plus, oops, I forgot my x plus 2, or negative 2, that's minus 2, x plus 5, and then x plus 1. Okay, so now we need to get our excluded values. So x plus 5 cannot equal 0, x minus 2 cannot equal 0, x minus or plus 5 cannot equal 0. One of those should be a minus. This is a minus. This is a minus. There we go. Sorry, this is a lot to keep track of, isn't it? And x plus 1 cannot equal 0. So when you go and you solve all of those for your excluded values, you get that x cannot be 5, 2, negative 5, or negative 1. So now you need to go ahead and cancel those out. So you can cancel your x minus 5s, cancel your x plus 5s, and cancel your x plus 1s. So then what you have left is x minus 1 divided by x minus 2. So there's your simplified rational expression, and there is number 7, your excluded values. So now we need to go ahead and factor number 8. So we're multiplying to negative 9 and adding to 0. Multiplying to negative 49 and adding to 0. Multiplying to negative 28 and adding to 0. Multiplying to negative 27 and adding to 6. So now let's go ahead and fill out those x's. So that's going to be 3, negative 3, 7, negative 7. Oops, not adding to 0. This one should be negative 3. Goodness gracious, Miss Humbert. Negative 7, 4. And this one you're adding to 6, so that's going to be 9 and negative 3. So now we need to write out all of our factors. So I have x plus 3, x minus 3, x plus 7, x minus 7. And then on the bottom, x minus 7, x plus 4, x plus 9, x minus 3. So I'm going to go ahead. Why don't you guys pause the video and you calculate out the excluded values yourself. Hopefully that's something you're comfortable with now. So now we can cross off x minus 7, x minus 3. And that's all we can cancel out. So up top we're left with x plus 3, x plus 7, and on the bottom, x plus 4 and x plus 9. So now, to multiply those two together, we have to use the box method. So that's x 3, x 7, and then the other box method is x 4, x 9. So we get x squared, 3x, 7x, and 21 when you multiply into the box. Again, I'm assuming this is something you remember. If it's not, bring it up to me and let's look at it together. And 9 times 4 will give you 36. So up top, we're going to have x squared. 3x plus 7x is 10x plus 21. On the bottom, x squared 4x plus 9x is going to give you 13x, and then plus 36. So that's your final answer. Now let's take a look at some of these word problems. So there are 25 lights around the piano. So we're going to start and we have 25 lights. Each light is 40 watts, and the cost of electricity is 50 cents per kilowatt per hour. Okay, so write expression to calculate the cost of the light. So what we're going to do is we're trying to cancel out labels, and so that we end up getting just the cost. We want to end up with money. So it's 25 lights, and that's going to be, each light is 40 watts. So there's 40 watts for one light. The cost of electricity is 15 cents per kilowatt per hour. So it's 15 cents divided by kilowatt hour. So every kilowatt spent per hour. So now what have we canceled out? Well, we haven't canceled out watts yet, right? Because watts is not the same as kilowatts. So we need to work on canceling out kilowatts. So let's do that first, okay? So we need to convert watts to kilowatts. Well, there are 1,000 watts per 1 kilowatt. So then we're going to take that, and now we can multiply by 15 cents per kilowatt hour, okay? So now kilowatt cancels, watt cancels, and light cancels. So I have the cents, and now I need to cancel out the hour. And we're doing this for 3 hours. So now my hours cancel, and now I need to multiply. So here's how I'm going to go through and multiply this. I'm going to do 25 times 40 divided by 1,000 times 15 times 3. So everything that's on top I multiplied, anything on the bottom that's divided, and I end up getting 45. Now if you need me to talk this with you in person, please let me know, because I know this stuff is confusing. So Justin Gatlin of the United States runs a 100-meter sprint. His winning time was 9.85 seconds. So for every 100 meter he runs, it's going to take him 9.85 seconds. And then it asks us what was his speed in kilometers per hour. So the first thing I want to do is take meters and turn it into kilometers. Well, we want to cancel out the meters. So our meters needs to be on top, and our kilometers needs to be on, our meters needs to be on the bottom, kilometers needs to be on top. Well, there are 1,000 meters for every 1 kilometer. Now we need to take seconds and convert it into hours. So I want my seconds up top to cancel with the bottom, and then hour on the bottom. So how many seconds are in an hour? Well, there's 60 seconds in a minute times 60 minutes in an hour. So the number of seconds in an hour is simply 60 times 60, which is 3,600 seconds per 1 hour. So now I've canceled out meters and seconds, and I'm left with what I want, which is kilometers per hour. So in my calculator, 100 divided by 9.85 divided by 1,000 times 3,600. So then what you end up getting is 36.55 kilometers in 1 hour. Okay? Let's take a look at number 11. The velocity of a spacecraft in order to escape Earth's gravitational pull is escape velocity. So if it's leaving the Earth, it's 40,320 kilometers per 1 hour. So now we want to convert kilometers to meters, because we're trying to put this in meters per second. So kilometers needs to go up top, meters need to go on the bottom. There is always 1,000 meters for every 1 kilometer. Likewise, when we're doing hours to seconds, there's always 3,600 seconds for every 1 hour. And we place the hour label and the kilometer label so that they will cancel out. And you notice what we have left is meters per second. So that's 40,320 times 1,000 divided by 3,600 gives us 11,200 meters per second for number 11. Lastly, let's take a look at number 12. While traveling to Canada, Joshua bought some gifts from home. She bought 2 t-shirts that cost a total of $21.95. If the exchange rate was $1 to 1.21 Canadian dollars, how much did Johanna spend in US dollars? So we have 21.95 Canadian dollars. So when we set up our exchange rate, we want to have US dollars to Canadian dollars because we want those Canadian dollar labels to cancel out. So there is 1.21 Canadian dollars for every 1 US dollar. So really all I have to do is take 21.95 and divide it by 1.21. And that's going to give us 18.184 US dollars. So that concludes your note video for today. Go ahead and show me a completed note sheet when you are done. Thanks for listening.